I'm Frances Knably. I'm here at the Works Museum, and today I get to talk to Austin Granger. Austin designed and built our huge K'NEX ball machine, and today I get to ask Austin lots of questions that we get from our visitors all the time. Thanks for talking to me, Austin.
Yeah, thanks for having me.
So I wanted to ask you first and foremost, it's been a really long process to get here. Is the machine finished?
With something like this, I never really can feel comfortable calling it finished. I mean, I always, every time I look at it, I see something that like, oh, I could do that a little bit differently. Oh, I could add something more on here. I could fix this part up a little bit. I could change that. So I don't know if this will ever really be finished, but we're calling it finished for now. It has 115,000 pieces. There's 12 different ways for balls to get to the top and bottom. And there's about 40 balls running in the machine at any given time.
It's a lot.
So I think that's a pretty good stopping point for me right now.
Awesome.
So the first thing that I do is I look at the space that I have to work with. And when I first got invited to the Works Museum, I was just completely overwhelmed by how much space. Previously, I'd been building these in my bedroom, and I was very tightly limited in space, and I just saw this giant 2-story tall atrium here and just thought, wow, I can do anything in this space.
So do you know exactly where everything's going to go before you get started?
I don't. In fact, I actually have very little idea where anything is going to go when I get started on a project like this. So what I'll do is I start by building the base framework that's going to support everything. So I build these big towers and I build beams that connect them, and I don't have a clue what's going to go on any of them. I just build them, I just fill the space, and then just think, this seems like a thing that could support some stuff later. What I do after that is I work on individual elements at a time, and an element is something like, say, these loop-de-loops right here, or this plinko board right here. It's just one little interesting feature that the balls will roll through. So I say, when I was building these loop-de-loops here, I just built them completely separate from the machine. I was just thinking, I'm going to build some loop-de-loops, and I put them together, and I had no idea where they were going to go. After I was done, I started sort of holding them up and saying like, well, do they fit here? Do they fit here? And I find a space where they're going to go, and I attach them. And once they're attached, I figure out a way to connect it in to the rest of the structure. So it's a very organic, very free-form process where I come up with very small pieces one at a time and put them together to form the whole structure.
I think that's really important, because I think that a lot of people would look at this and they would say, oh man, that must have taken so much preparation and planning. And there is, but not in the way of, you don't have a step 1, step 2, step 3, step 4, all the way to 100.
Exactly.
You're figuring it out as you go along.
Exactly. Yeah, I'll come in here to work on it, and I have no idea what I'm going to do that day. I just, sometimes I just dump a box of parts on the floor and see what inspiration strikes. I say like, this looks like a thing that might be cool. I'll try to build that and see if that goes anywhere. Cool. So.
Some of our visitors probably remember the K'NEX machine being very different at one point. And there was one major thing that I know of that made you really want to change it up. And I was wondering if you could talk about that.
Yes. So what you're looking at here is the original machine. This was built back in 2013, and it took me about 4 months. And this machine had one big flaw, and that was its chain lift. The machine is 23 feet tall, and the only thing getting the balls from the bottom up to the very top is the chain lift that you see right here. And if you'll notice, the chain lift is made up of individual connected links. And the links are just little plastic hooks that are snapping into each other. And when you have hundreds and hundreds of plastic hooks running over and over and over again, 8 hours a day, they're eventually going to come loose. And when they came loose, that was a really big problem, and it took a lot of people a lot of time to put them back together. And as the machine was getting older and older, that started getting worse and worse. So we just thought there's got to be a better way to do this.
Were there different things that you tried to replace that with?
I thought a lot about different methods that I could get the balls up to the top. I thought about a Ferris wheel style lift, or a corkscrew lift, or a series of arms or buckets that lift them up. The biggest thing with making a new lift that's more reliable is to reduce the number of moving parts and reduce the number of places where something could come disconnected. So the solution that I came up with for a more reliable ball lifting system was this elevator that you see descending right here. And these elevators, instead of being connected by a whole bunch of tiny plastic links, are connected by one string. And this one string is tied off on one end, it goes up and over the top, and then it's tied down on the other end. So the balls load into the elevator here at the bottom. It takes about 45 seconds to lift it all the way up to the top, where they are then unloaded. And from there, there's 12 different paths that they can take to get from the top all the way back to the bottom.
So you talked a little bit about how each of the components, you kind of create those first and then fit them in where they seem to go.
Yeah.
So you're not actually building them off of the structure that already exists,
Exactly,
right?
exactly.
So were all of them built here?
No, actually, a lot of this machine that you see here is parts of another machine that I built a few years ago at a place called Brickmania Toy Works. So what you're seeing here is my other machine, and you'll probably recognize some components that I've reused from that. You've got the big spiral bowl, you've got the giant loop-de-loops, multiple helix, and when that machine was taken down, all of the pieces were donated to the Works Museum, and that's where I got the parts to do this whole rebuild project. So the parts from the other machine at Brickmania were combined with the existing parts that we had here, which were a combination of parts that we purchased secondhand and parts that have been donated by guests coming to the museum.
It's really cool. So visitors did contribute a lot of the connects that are a part of the machine now.
Yeah, and between all the donations and all the pieces we bought, we have a collection of about 200,000 pieces to work with.
Oh my goodness. How many pieces then are in the machine?
Right now, there's about 115,000 pieces.
Wow. So what do you think is your favorite part of the K'NEX machine?
That is a really tough question, but I would have to say it's probably the big spiral bowl here. So when I first built this for the ball machine at Brickmania, it took me about 2 months just to build this section right here. So this has about 20,000 pieces just by itself here. And it's a whole lot of very intricate curvature, getting the spacing just right, making sure everything lines up, getting the angles right. And it was a lot of trial and error involved in actually getting this to work the way that it is here. So when the parts from my old machine were donated here, I really wanted to save the spiral bowl because I liked it so much. So we actually moved it all in one piece on a big truck and brought it here and added it to this machine.
Awesome. So the spiral bowl to me is just, it's really recognizable as like a gravity well. Lots of times people see them with like coins going around.
Exactly,
is that where you got the idea?
Yeah, it is. It was actually one of my coworkers who said, like, hey, what if you built a big coin funnel but for balls? And I just thought that's a really good idea. So I did a couple of really quick sort of back of a napkin type sketches and figured out roughly what I wanted to do and then just got started with building.
I'm guessing this isn't the only place where you've like looked for inspiration other places. Are there other elements that you've built that are based off of things you've seen or experienced out in the world?
Yeah, definitely. You'll see there's the giant Ferris wheel here. It's actually just about to start spinning right now. That ball's coming down into it, and there it goes. So the weight of the ball going into the Ferris wheel is what's making it spin there. And that was something that I wanted to do right from the beginning. I knew I want to do something that's like a Ferris wheel on here. I want to make it gravity powered. I want it to be really big. Unfortunately, it's been a little bit covered up by everything else, but you can still see it moving there. There's also the giant loop-de-loop in the background here you see with the rainbow colored lights on it. Usually when I do a loop-de-loop on a ball machine like this, it's a lot easier to build these perfectly circular loop-de-loops like this. But if you notice on a real roller coaster, they're more teardrop shaped. And the reason why that is when it's going up on the loop-de-loop, it's going up, and so it slows down. And so in order to be able to stay on the loop-de-loop without falling off, it has to become a tighter curve for the top half of the loop, and then a more gradual curve at the bottom. So when I built this loop-de-loop, I first built it as a giant circle, and then found that the balls were falling off when they got to the upside down part. So I actually did have to draw inspiration from actual roller coasters to make the proper teardrop shape for the loop.
Okay, that's really cool. I didn't know that. That's really awesome. Science!
Another source of inspiration for the design of the machine was the design of the ball elevator. And this is actually based off something called a funicular railway, which is a type of train that can go up a really, really steep hill. And the way that it does that is it has one train going down at the same time as another one is going up. And instead of the wheels turning on the track to drive the train, they're attached to a string. And because they're both attached to the same string, one of them acts as the counterweight for the other. So it pulls the other one up as it's coming down. And that's exactly what you see happening with the elevators here. As this elevator is going up right now, the one on the other end is going down and pulling it so the motor doesn't have to work very hard.
So it's utilizing the weight of the other car to help pull itself up.
Exactly.
So I've noticed that sometimes when the machine is running, all of a sudden there will be balls. Sometimes we see them on the floor, our visitors will spot them. So when things come off the rails, how do you begin to look and figure out what's going wrong?
The first thing is to try and figure out where is it coming off the rails, and that can sometimes be hard to do. You know, I'll sit here and I'll watch the machine sometimes for an hour just trying to find where something's falling off. And as soon as I see it, then I'll take more balls and I'll put them back down again and again, and I'll try and figure out exactly, okay, what is it that made it fall off? Is it going too fast? Maybe it hit something, maybe it wasn't going fast enough. And then I think about, what can I do to fix this problem? If it's going too fast, maybe I can slow it down. Maybe the ball hits something, and when it hits something, it loses a little bit of its speed. If it's going too slow, maybe I can make the track a little steeper. If it's falling off on a curve, maybe I can put a wall on the outside of the curve so that it can't escape the track that way.
So where are some of the is there like a place where you've had to make one of those changes that you can point out?
Oh yes, all over the machine. You'll see in a lot of different places around the machine, you'll see little walls like this. And they may not look like they're doing anything, and 99% of the time they don't, but it's that 1 in 100 balls that might just skip the track right there and fall off onto the ground, and that's what these are there for.
So when you're, looking at the balls, you're seeing them fall off, are there ever moments when you can't figure it out and you get frustrated?
Oh yes, all the time. When a ball comes clattering down through the machine and I have no idea where it came from, and I'm looking at it, and of course, when you're looking at it, of course it's not going to fall off. It's the 1 second when you turn your head away, then boom, it falls off. And honestly, sometimes I've even set up cameras to watch spots that I think are troubled, and then I'll go through and I'll look at video footage, and then finally it's like, aha, I've got you now. And then, it's always something really simple like, oh, I just need this one piece right here so that it can't slip out through that little hole right there, something like that. Something I just missed the first time around.
It's always like the simple little thing.
Exactly, yeah.
So when you have those moments and you're just like, I can't get it, what makes you keep working on the machine?
Honestly, I enjoy the problem-solving process so much that even when it's frustrating, that's still kind of the part that I really enjoy. Because when you're solving a problem, you know that eventually you're going to come up with a solution, and the solution that you find could end up being really, really cool. So, sometimes if a problem's really frustrating, I'll just take a break from it and work on something else. And that's really helpful too, because sometimes, I'll come back to it, and sometimes I'll solve it in 2 minutes where I took 2 hours the day before. But that's really my favorite part, because when you just put it together and you know it's going to work, to me there isn't really all that much fun in that. It's all about figuring it out, and it's like, okay, I'll test it. It didn't work. Okay, now why didn't it work? Can I try and figure that out and make it work better the next time?
Awesome. So, Austin, there's a lot of people that come in here and they're just in awe of this thing, and they look at it and they see this huge thing that you've spent so much time on. And what they'll say is, I hear it all the time, they'll say, I could never do something like that.
I hear that a lot too, and it's honestly disappointing when I hear that, because of course you can do something like anyone can do something like this. You just have to break it down into small pieces. Like I was saying earlier, every single element, every single track, it's its own little mini project that you can do just by itself. So you can say like, today I'm going to figure out how to build a loop-de-loop, and that's the only thing you focus on. Just say like, I want to make a ball go upside down on a loop, and that's all that you think about. And you figure that little part out, and then the next day you say, okay, I figured out the loop-de-loop, now I'm going to figure out how to attach it and make it strong. and you get that. And the next day you say, okay, now I'm going to figure out how to make a track that goes into it and another track that goes out of it. And it's these tiny little steps, one at a time. And you'll surprise yourself, honestly, with how quickly something like this comes together. Like, I'll be so focused on just a little thing, a little part of this machine, that then suddenly I just take a step back and it's like, whoa, did I actually just build that? I was just building loop-de-loops here, and suddenly it's this whole thing. So yeah, I firmly believe that anyone can build something like this. You just have to break it down into small steps.
And that's probably true not just for K'NEX, but like any big project that somebody wants to try, just breaking it down. Did your first ball machine look anything like this?
It definitely did not.
Do you remember anything about it?
Okay, it's December 20th, 1998. We're going to look at Austin's new K'NEX machine.
Yeah.
The first time I ever built anything like this with K'NEX, I was probably like 10. The first time I ever built something large-ish that was along these lines, I was probably 16 or 17.
So Austin, something that we get asked all the time here is, how long did it take for you to make the machine?
And that's another really good question that doesn't just have one answer, because this is really two different machines that have been put together. So, as you mentioned earlier, back in 2013, I started building a smaller machine in this same space, and some of it is still here. The green tower on the right side of the machine, that's from the older one. Some of the other stuff is new. Some of the stuff was brought from my second machine at Brickmania. So, the first machine took me about 4 months to build, and that was it. Then it was done. That was all there was to it. And then I started working on my other machine at Brickmania, and that took me another year on top of that to build. And then we thought, okay, what if we combine the two here and make an even bigger one? So I had to take apart the one at Brickmania. That took like 2 months just to take it all apart. I had to move all of the pieces here, and I moved them all in big sections because I thought, well, if I move them in sections, that'll be less building that I have to do here, and it'll go faster, right? Well, it still took me a year. So I took those sections, I assembled them together as much as I could. There was still a whole lot of new building that I had to do. So once I got started building the machine here, until this point now when I'm considering it finished, that took me about a year of rebuilding. So this project took me 1 year. All of the building involved here, probably about 2.5 to 3 years in total.
And all of that is happening when you have a million other projects and things going
Yes.
on. So you don't even get to work on it constantly.
Right, yeah. This was all done just in my spare time, coming in here after work, on weekends, just whenever I had a free minute. And another question I get asked a lot, it wasn't just me who was building this. I did have a lot of friends volunteering their time as well, coming in and helping. A lot of my friends were actually really helpful in solving some of the biggest engineering problems I was having with this, helping me design the elevator, helping me work out new tracks, where tracks should go, how they should be interconnected. So I do want to give thanks to all of my friends who helped out with this project, because I really couldn't have done it without them.
So I know that when I'm working on like big projects in the museum, I get stuck a lot. And for me, the biggest thing is being able to have a team, have people that I can reach out to and ask for help. So you have those people too. So even though
Yes,
you
I
have
do.
this like big design and this big, all of this expertise in building with this, even you need to ask for help sometimes.
Exactly. When I was trying to come up with the design for how the balls get loaded into the elevator here, I got really stuck a lot. I made probably a dozen different prototypes trying to get it to work, and it just wasn't working the way that I wanted to. So I asked one of my friends, I said, how would you do this? And he said, you know, what if you make the entire ramp tip over onto its side and have the balls roll down the side rail? And I just thought, that's genius. And we tried it, and it worked right away. And sometimes you really just need a completely different perspective on it in order to work through a problem like that.
So I know that like a new challenge for you in this spot was like building around this staircase. How did you approach that?
Yeah, that was a very interesting challenge. Usually I'm only building maybe 4 or 5 feet off the ground, but now I can work 23 feet off the ground, and that was definitely an interesting challenge to work with. And a question I get asked all the time is, how did you build it up so high? But what I can do in this space is use the staircase to my advantage. So you might actually notice, if you look at a lot of the elements that are on the machine, a lot of them, like this green spiral here, they're placed perfectly so that I can reach them from the stairwell. So you notice down in the corner there where you can't reach anything, there's not really anything interesting going on. And again, way up at the top there, not a whole lot going on. And that's just because I can't reach that without a huge ladder. So
you had to strategically place things so that you could maintain them.
Exactly.
Okay.
So all of the parts that I felt would be requiring the most maintenance, I tried to make sure that they were placed within easy access of the ground or the stairs or the landing up at the top here.
So the balls are all obviously getting down to the bottom of the machine in very different ways. What determines which way the balls go and what path they take?
So when a ball starts from the top of the machine here, it goes onto this series of rocker switches. And when the ball falls and lands on a rocker switch, the weight of the ball actually makes the switch flip direction. And then when it's flipped direction, it's ready for the next ball to send it the opposite way that it just came. See, this ball's coming through here, flips those two switches, the next one's going to come and go a completely different way. So there's 12 possible ways that a ball can get from the top to the bottom, all interconnected through this series of switches.
So Austin, can you tell me more about how the elevator actually works?
Yeah, absolutely. So up at the top of the machine here, this is where all of the mechanical behind the scenes for the elevator is going on. So this big complicated gearbox is what drives the entire elevator system. And there's a very strong motor and a whole bunch of gears that are turning a pulley. And the pulley is pulling the string up while lowering the string on the other side. And you see it's pulling up this elevator, coming right up through here. And this elevator can carry up to 8 balls at a time. What it's going to do, when it gets to the top, you see that wheel there, it's actually going to follow the track and ride along it to tip the elevator over and dump all the balls out. Then it switches direction and goes back down and starts pulling up the next elevator.
So when the elevator is coming up and it dumps the balls, how does it know to turn the motor around and send that elevator back down?
So up at the very top here, there's these tiny little switches. You see it's just a little metal finger sticking out there. And the elevator will actually hit that, and that sends the signal to a small computer inside the transmission that tells the motor, hey, there's an elevator. Stop for a second, let the balls all come out, and then start spinning the other way until you get the signal from the switch on the other side that the other ones come up to the top. So one of the issues that I had with the elevator is it dumps 8 balls at a time, but I don't just want all 8 balls to go rushing through the machine all at once. I want there to be some constant motion going on where it's one ball, then a pause, then another ball. So there's always something going on even when the elevators aren't dumping the balls out. So I built this regulator wheel here. So you see it's this 4-sided wheel, and it fits exactly 1 ball at a time and lets it go through. So there's a group of balls waiting in this basket back here while it's letting 1 ball at a time go through, and by the time the basket's empty, the next elevator is just getting to the top to dump out the next load of balls.
So I know that you spent a lot of time figuring out how to do this transmission.
Yes, definitely.
What were some of the challenges?
So one of the biggest challenges was just how to get it to switch directions in the first place. I didn't start using a computer or switches or anything like that. I was trying to do it just with levers and gears and only mechanical stuff. So initially I had it when an elevator would get to the top, it would hit a lever and that lever would flip over the other way. And when it flipped over, it would switch a gear inside a gearbox that would make it start spinning the opposite direction. And it was very complicated. I built probably 10 different versions of that transmission over about 4 or 5 months, and it was just not working. And eventually it got to the point where I said, okay, I need to do something completely different because this is not working the way I want it to. So I put the little switches in, I put the computer in, and that has worked much better.
So I remember a time when you had just installed that first version of the transmission, and the elevators sometimes would come up to the top and they just wouldn't be able to turn around.
Yeah, that was an interesting problem. So the way this string is going around the pulley here, you can see in there it's actually wrapping all the way around and coming out the other side. The problem is, this only works if the string is being pulled on really, really tight, because then it kind of grabs the pulley. It's like gripping onto it, and it won't slip through. And that only works if both of the elevators are pretty heavy. So if I make this side lighter by just holding onto the string, you'll see now it's stopping, and it's just slipping around over that pulley there. So the problem I was having is, you have one elevator that has a whole bunch of balls in it, and it's really heavy, and then it gets to the top and it dumps the balls all out, and now it's a lot lighter and it's not pulling on that string as hard anymore. So I thought, how can I make it still pull on the string just as hard, even though it no longer has any cargo on it? So you might notice inside of these cages on the elevator, there's actually a second elevator, and it gets picked up by the first one and carried along with it. And that second elevator, it's got a rubber tire in it that's very heavy, and it actually serves as a counterweight so that even though this doesn't have any balls in it, that second elevator and its heavy rubber tire are still pulling it down, so the string is still being pulled on really, really tight, and it can grip the pulley.
Austin, I'm noticing that there's like a ball stuck here. What's going on?
So this is actually a racing track. So that ball's not stuck, it's waiting for another ball. Watch this, when it comes right there, it lets them both go at the same time, and they're actually going to race all the way to the bottom. So when you see that happen, you can pick whichever one you want to win and see if it makes it to the bottom first. So this little release mechanism here, this will only go when it detects the weight of two balls. So one ball isn't quite heavy enough for it, but as soon as it gets another one on it, then it will release both of them at exactly the same time, and they can race to the bottom. Here, I'll grab this one off the spiral here. I'll put it on, and you can see they both go at exactly the same time. There they go. Oh, silver's winning for sure.
So Austin, what track do you think was the hardest for you to figure out?
That would have to be the giant loop-de-loop, the one with all the lights on it in the back of the machine there. I thought that track was going to be pretty easy, and it was not at all. So I put the loop-de-loop in place, and then I realized, wait a minute, I don't have enough space for a big drop to get enough speed to go all the way through the loop. So I had to pick it up and I had to move it and put it somewhere else, and then that didn't work, and I had to keep moving it around and around, trying to find a space where I could put a big sloping drop into the loop. And the problem I was having was that drop can't be too steep, because if it gets really, really steep, the ball isn't going to roll, it's just going to fall and kind of slide and skip down. And if the ball isn't rolling, then once it gets to the loop is going to be like, hey, you're not rolling, you're just going to slide and slow down, and so I'm going to have a lot of friction pushing against the bottom of the loop, trying to get the ball to start rolling, and then it's not going to have enough speed to make it all the way through the loop. So I had to push the loop really far over, actually sort of building it through one of the towers just to get enough space, and it probably took about a month just to get that part working. It was actually pretty frustrating at times, but it's working pretty well now, and I really like it. It's one of my favorite tracks in the whole machine.
So Austin, before we go, my last question for you. What do you think is the best question that you've received from a visitor?
So when I was still working on the design for the elevator, I thought that I was pretty close to having a final design. It was working pretty well, but it was just a little bit slow getting balls to the top. And I actually had a kid come up to me and he said, "Why is the elevator so slow?" And I said, well, because the motors aren't that powerful and it takes a long time. You have to gear it down and make it run slowly so that it can carry something really heavy up to the top. And he said, well, can't you make it go faster? I didn't really have a good answer for him. And so I thought, I think I can make it go faster. And because of that question, I went and I redesigned the elevator again, and I made it go faster.
Oh my
because
goodness.
I couldn't come up with an answer to that was no. No, there shouldn't be any reason why this can't go faster. So I got a more powerful motor, and I built a stronger gearbox, and I tested and I retested, and it runs now about twice as fast as it used to.
So we have that that kid to
Yes,
thank
yes,
for
exactly.
part of the ball machine. That's really cool. Austin, it's clearly a labor of love that you've put in here at the Works Museum, and we are so, so grateful. And thanks for answering all of my questions today.
Well, thank you for having me.
Yeah.